Friends, today we are going to discuss our second part of the classification of elements and periodic table. In this video, we will be going to discuss the Mendeleev periodic table. In the previous video, we have discussed about the history of the periodic table, how there is a contribution of the different chemists over a period of time that we have observed in the previous video, and we have discussed in detail. Mendeleev was the father of the periodic table. Apart from Mendeleev, Lothar also there is a huge contribution towards this development of the periodic table. But before the Lothar Mendeleev published his periodic table and his periodic law. Basically, the periodic table of the Mendeleev is based on the periodic law. So let us first understand what is the periodic law of the Mendeleev. Periodic law, it states, it is a very important law, I would say. It states the physical and chemical property of the element. Physical and chemical properties of the element. Properties of the elements are the periodic functions. Periodic functions of their atomic masses. The physical and chemical properties of elements are the periodic functions of their atomic masses. And the periodic table is based on this law, which having in the periodic table of Mendeleev, you can see this is very much close to the modern periodic table that we will discuss in the later videos. What we found, there is a very close correlation between the periodic table given by the Mendeleev and the long form periodic table. In the Mendeleev periodic table, there is two things that we will understand. Number one, that is, it is having the 8 groups. It is having the 8 groups and having the 7 periods. The vertical line is called the groups and the horizontal rows are called the periods. And sometimes it is called by the Mendeleev as a series also. But after the event of the inert gases, there is another group has been added to this Mendeleev periodic table, that is the zero group. Mendeleev periodic table, that you can see that the element has been arranged in order of increasing of their atomic masses, and the elements are being placed so that in the vertical column there will be the elements which will having the similar properties has been arranged in the vertical column. In the horizontal row, that is called the period, there you will find the elements which having the different properties are being separated away from each other. So there is the 8 groups and one group that is a 0, and there is a 7 rows, that is called period. So let us constitute the Mendeleev periodic table. As we have observed that it is having first let us have the group 1, group 2, group 3, group 4. One, two, three, four, 5, 6, 7. So this is a first series, or you can say period, second, third, fourth, fifth, sixth, and seventh. This is all our groups, and this is your period. Now we place the element. The most simplest element you know, that is hydrogen, and it is having an atomic mass of 1.008. In the second period, that the first element is helium. This is helium, and it is having the atomic mass is 4. Then lithium, it is having atomic mass 7. Then beryllium, it is atomic mass 9. Then boron, it is atomic mass 11. Then carbon 12, nitrogen 14, oxygen 16, fluorine is 19. Here there is no element on the group 4. Group 8. In the group 8 there is no element. Again we start here from the neon. It is having the atomic mass 19.5. Then sodium, it is 23. Magnesium, it is 24. Aluminium, it is 27. Then silicon, it is 29. Then phosphorus. Then phosphorus is 31. Sulfur is 32. And here that is chlorine is 35.5. Now we start the fourth period. The first element of this is argon. Argon having the 38.5 atomic mass, and after that potassium is 39. Then calcium is 40. Then you have the scandium, titanium, vanadium, chromium, manganese, and the Fe, CO, and Ai. That is the 3 elements. Okay. Then in the fourth periodicity there is an element. It is copper, then zinc, then you have the next element, that is gallium, then germanium, then arsenic, then there is an element that is your selenium, and that is bromine. In the fifth period you will find it is start with the krypton, then rubidium, strontium, yttrium, zirconium, then niobium, molybdenum, technetium, and there is ruthenium, rhodium, and palladium. In the fifth group it is started again from the palladium, Ag. In the group 1 is Ag. Then you will find cadmium. Then again indium, then Sn, then Sb, antimony. Then you get the tellurium, and there is you can get the iodine. So you can see in that every period there is a 2 rows of element you can find, right? Then in the next 6th group it is started with the xenon. In the 0 group all are the your noble gases. Xenon, then cesium. Next element of the cesium is barium. After barium, lanthanum. Then hafnium, HF, hafnium. Then tantalum, this is Ta with tantalum, and then tungsten, then rhodium, rhodium. Then you have iridium, not iridium, here it is osmium, iridium, and platinum. After the platinum, here Au, gold, then Ag, mercury, then helium, Pb, bismuth, then polonium, and astatine. So these are all the elements in the 6th period. In the 7th period, it is started with the noble gas radon, then francium, then you have actinium, then you have actinium, then protactinium, then you have the protactinium, sorry, here there is thorium, then protactinium, and then your uranium. So you can see this is the periodic table, that is the Mendeleev periodic table. In the Mendeleev periodic table, you can see one thing very clearly, that he has arranged the periodic table, the element in the periodic table as increasing their atomic masses, and he kept all the elements in the vertical column which is having the similar properties. In the group you can see there is a two type of metal element. One is your normal element and other is your coinage element but transition element. You can see here, this is copper and this is potassium, this is rubidium and this is Ag, this is Cs, cesium, and this is Au, gold. So there is a one element that you can see, this is a normal element, and other that is transition element. Another thing is that some of the elements that I have written here, that is here this is the gallium or germanium. At the time of when the Mendeleev gives the periodic table on the basis of the periodic law, these two elements was not there. But he predicted there, after that discovery, there must be two elements. This is called the Eka aluminum and Eka silicon. And after that, it has been discovered afterward. So you have the gallium and you have the germanium. In this way, lot of elements, all the elements that we have written here, not being at the periodic table of the Mendeleev. As for example, that is that technetium. This is not actually in the periodic table of the Mendeleev, and this is not there. And there is another. You can see the rhodium here. That is a rhodium, and radium. This is radium and ascendine. All those things that elements are not being discovered at that time. So you can see the periodic table of the Mendeleev is very much elaborate because of the fact what he has done, he completely relied on the similarity of the empirical formula as well as the similarity in the properties of the compound made by the element. And in doing, sometimes what he has done, you can see the tellurium having the greater mass, it is having 127 mass, and the iodine it is 126 point something. You have kept the tellurium before iodine, in spite of the fact it is having the higher atomic mass than the iodine, because he much more emphasizes on the similarity in the properties, because he placed iodine here because of the fact all the halogens having the similar properties. So this is the Mendeleev periodic table and all the elements has been written here, and later on what we are going to discuss, we are going to discuss how this Mendeleev periodic table is correlated with our modern periodic table, modern long form Gauss periodic table, that we will understand. And you can see here also that this is the FeCO, ruthenium, rhodium, pravium. These are basically called the triads. There is a total 9 elements of triads, and in the in your Doberanus triads also. It is, you can see here, this is the Doberanus triad, this and this, lithium, sodium and potassium. Also you can see that is calcium, strontium and barium. Also this is also the Doberanus triads. Here also you can see that chlorine, iodine and bromine all are the triads that we have discussed in our previous videos. So we can understand the Mendeleev periodic table is a very elaborate form than other periodic table than the previous by other scientists, and you can see that is very much close to the modern periodic table. So that is all for today's video. We will discuss later on different things in this video, that is the modern periodic law. Modern periodic law is basically when it is observed that atomic number is much more correlated with regard to the properties of the elements than the atomic masses, and this has been, atomic masses has been changed to the atomic numbers. That we will discuss in the next video with some examples which in the examinations may come, that we will discuss later on. So all the best and be best, and if you like this video you can circulate it, you can share to your friends. Okay, all the best. Thank you very much for listening.